Hi everyone, let's discuss another exam question. The diagram shows a coin being dropped from a height. The graph shows how the velocity of the coin changes until it hits the ground. Okay, we have been given a graph, a velocity time graph, and it's a straight line to the origin. So when you see the straight line through the origin, you can understand that the initial velocity is zero. Because when the time is zero, the velocity is zero. So the initial velocity is zero. And it's a straight line. If it is a straight line, the gradient is constant. If the gradient is constant, since gradient represents velocity, acceleration should be constant as well. So these are key information we can grab from the graph. What happens is when the coil is dropped, its velocity, initial velocity, has to be considered as zero. That's a keyword. So you can see in this question, it says the diagram shows a coin being dropped. So when you see the word dropped, you need to assume that initial velocity is zero. Initial velocity is zero. From the graph, we are able to identify the final velocity is 6.1 meters per second and the time taken to hit the ground. But that is the point where the graph finishes. That is 0.62 seconds. So you can identify these values from the scale. How can we measure the height or the displacement? Displacement is the length between the initial position and the final position, straight line distance. Basically, we can say that's the height the coil was dropped. How can we find that? We can find it from the area under the graph, because we know that area under the graph of velocity time graph gives us the displacement. Gradient gives us the acceleration. Area under the graph of velocity time graph gives us the displacement. Question number 1 is state the equation linking acceleration, change in velocity and time. So they have clearly stated what we need to use here, changing velocity and time. And it's just to state. So our command word here is to state. So you just have to write the equation. Acceleration is equal to change in velocity. That is final velocity minus initial velocity divided by time taken. And there is 1 mark allocated for this. So to get 1 mark, you just have to write this equation. Moving on with the second question. The coin hits the ground in a time of 0.62 seconds with a velocity of 6.1 meters per second. Calculate the acceleration of the coin as it falls. Give the units. How many marks given to us? 3 marks. So we need to find the answer. There's a 1 mark allocated for the answer and there's a 1 mark allocated for the units. So the other mark is allocated for your substitution, basically your workings. So your working should indicate that you are using the previous equation that you have already written as the answer for the previous question. That is A equals to V minus U over T. So you don't have to write it again because we need to save time. So answer should be acceleration is equal to final velocity. So what is our final velocity? 6.1 meters per second. What is our initial velocity? That's 0 meters per second. And the time 0.62 seconds. So all these are given here. All these information are given to us, and we know that it was dropped and the initial velocity is 0. Even you can find these out from the graph itself, like I have showed you. So then we got to find the acceleration. So our acceleration becomes 9.8, and the units will be meters per second square. Right? And then the third question is to state the feature of the graph that shows the acceleration. So now what is the keyword here? State. Not the keyword. Action word is state. So what are the keywords? The feature of the graph and the acceleration. The feature of the graph that shows the acceleration. So these are the keywords, and state is the command word. Is the command word or the action word. These are keywords. So let's say these are keywords. K. Command word is state. So you just have to state what is represented by the what represents the acceleration, which feature represents the acceleration. So it's gradient. So we know that it's just only that one word, gradient, which you have to write as the answer. Sometimes I see that students write lengthy sentences just to get 1 mark. So you need to understand it's just 1 mark, and it clearly says that you need to state. So it's just a one word that you need to write here. That depends on the keyword and the marks as well as the command word. Okay. Then calculate the height from which the coin was dropped. Use the graph to help with your calculation. Right. How do you find this? As we know, area which I'm marking here. So I'm shading the area under the graph. It shows the displacement. That is the height which the coin was fallen. So how do you find this? It's very easy. That is the area of the triangle. How do you find it? Half into base. So what's the base? It's 0.62. Seconds into height. The height is 6.1 meters per second. Right. Now we can calculate the area under the graph through this equation.